What's happening, guys? Today will be my first ever sponsored video. There's a local company called Custom Bytes who has supplied me with the components I need to build a PC. I'm building it for their store, which they will then later be selling at some point to a customer within the shop. But like I say, that said, today's our first ever sponsored video. After an ad here, we'll go over the components that we're going to be working with. So give me 1 second, and I'll show you what we got. Today's video has been sponsored by Custom Bytes. Looking for a PC to play all the hottest games? Custom Bytes offers no credit check needed financing. Check out www.customgamingcomputers.com and order your new gaming PC today. So we've got the components we're going to be working with laid out here. We've got a Gigabyte X570 Gaming X motherboard, Radeon RX 5700 from XFX, it's their Ultra series. We've got a Thermaltake 700 watt 80 certified power supply. We've got a 32 gig kit of Corsair Vengeance Pro DDR4 3200 megahertz. We've got AMD Ryzen 2700X processor. We've got a 500 gigabyte Western Digital Blue NVMe solid state drive for the operating system. And then we have a 2 terabyte Seagate Barracuda drive for additional storage. And for the processor, we're going to be using a Cooler Master Hyper 212 Evo. Oh, and to polish it off, we've got here, I can't pronounce this company's name. I think it's like KZYEE, and maybe the K is silent, but we've got an RGB fan setup here. This is their gaming PC cooling ice storm setup. So it comes with 5, and then he's supplied me with a couple more fans, so I'll have enough to run the entire PC's layout. And then for the PC case, we'll be using the Inwin 101. I've actually used one of those in a video before. I'll go over here and show you guys. Just got the box here right now. I don't have this out of the box yet, but these are really cool looking. I'll show you guys here in a minute. So we'll get everything unpacked here, and then we'll get started, and I'll show you guys kind of the process as we go through it. We're going to try to work on some really nice cable management. Since this is going to be shown in the store, we want it to look good. So I'll be right back here in a moment once I get everything kind of out of the box, and we can start kind of looking at what these things come with and then how they all go together. Be right back. Alright, so I got a few things out of the box here. We've got the Western Digital M.2 NVMe drive here, which supposedly runs at a speed of 2400 megabytes per second, which isn't too bad as these things go. It's pretty standard. Should use PCI Express 3.0 lanes. We've got the 2700X out of the box. It's funny that they give you that big box. Usually they have a cooler in it, but we're not using the stock one. So like I say, sometimes though, like I say, the newer ones, like the 3950X, for example, this is what you get in a box, and there's no cooler with it half the time on some of those things. I think that's funny. But anyways, we've got our cooler out of the box here. Comes with mounting hardware and so forth in this little container here. We've got a set of instructions. We've got mounting hardware for different brackets like AM4 and 1150X, as they call it, because it'll work on like 1150, 1151, the different versions of sockets that Intel's put out here in the last few generations. So that'll work on our AM4 board. I'll just have to go through the instructions to find the correct mounting hardware to get it to work with this board. We've got our Corsair Vengeance Pro RGB memory, which is pretty nice looking stuff. I've used this before in previous builds, so I kind of like it. There's our Seagate drive. So I'm going to take it out of the package until I'm ready to use it. There's no reason to expose it to the air until I get it done, get ready to put it in the system. And the power supply, this is not a modular power supply, so everything is attached to it, but it comes out, all you get in there is some bubble wrap. It comes with everything kind of tied up with like a twist tie, and we've got our standard power cable here, so no big deal there. Next thing up, we're going to go ahead and be getting video card and motherboard out of their respective boxes, and we can see what comes with those. I suspect there won't be a ton with the video card, other than maybe like some power adapters or something. But I'm kind of curious what Gigabyte is including with this box, like what, how many SATA cables, you know, like does it have an SLI bridge? I'm not sure the layout of this board exactly. I don't know if this is a standard ATX or if this is like a micro ATX. So we'll look here in just a second. I think it's standard. But 1 second, we'll get it out of the box, we'll have a look. I don't know how well you can see it through this reflective bag because the light's shining right down from above. It's not really handy for this, but it does appear to be a full ATX motherboard. We'll get it out of here, the plastic, here in a minute whenever we're ready to start putting it in the system. I just, again, don't have any reason to pull it out of here and expose it to potential static discharge until it is ready to go. But like I say, at least we've got looks like a main PCI Express slot with kind of like a reinforced armor coating around it, and then a secondary. It probably runs at 4x, but there's a secondary PCI Express slot. That's how a lot of these work, where if you're using a certain number of lanes up for like the NVMe and then the main 16x slot, they might give you another 16x slot physically that runs at 4x, and then we've got a couple 1x PCI Express slots in there. And then if you can see it here, again, it's kind of reflective, but there is a heatsink supplied that covers the M.2 slot where we'll be installing our Western Digital drive, so we have a little protection for that and to keep it from getting too hot. So that's nice. We got 4 DIMM slots for memory. Got our 24-pin 12-volt power supply connection for the motherboard there. We've got CPU 8-pin up there. Again, I probably will stop going over this right now because again it's just too reflective, but you get the general idea layout of the board. Comes with the manual as expected. We've got a driver disc, and we've got a couple, like a different mounting screw and retention screw for the M.2 drive. So I don't know if there's already one underneath that heatsink or not. It looks like there's already one at the end of it, so maybe that's movable, maybe it isn't. Maybe that one's to secure down the heatsink, and then this is probably to secure the M.2 drive. Some of them come in different lengths, so I think that's why they give you different points where you can mount the retention screw on the board and then connect your drive at that point. And then they gave us a couple SATA cables. We'll only need one of those for the Seagate drive. We will not need one for our M.2 because they don't need a SATA cable, which is handy. Looks like there's actually a second, I didn't see it, but there's a second M.2 slot down here below the other PCI Express slot, so that's handy. There's actually 2 of them, but they do only supply you with a single heatsink. All right, I'm gonna go ahead and open up the video card here. One sec. All right, we got a video card out of the box. It comes with a, first thing that you see is a little card here that warns you that you need to go download a driver because it doesn't include a driver disk with the card. There's a little warranty card here and something about thank you for your purchase. Please take a moment to write a review at their site. And a little support information, that kind of stuff. It did come with a couple power adapters, so you've got this converts two 6-pin PCI Express to an 8-pin because a lot of power supplies are insufficient in that regard. I don't know that I'll need it with, I didn't go ahead and read the box, I should have done that, but I don't know if I'll need it with this or not. I think this should have a couple of 8-pins. There's an 8-pin, there's an 8-pin, so I don't need it. We got also a pair of Molex to 6-pin adapter. So again, depending on what you're needing, which this card appears to have an 8 and a 6. That's probably why they give you a way to make an 8 and a 6. That would make sense. It's still got the plastic covering on the card, and we've got, it's pretty freaking massive, I want to say. Like, you know, I've got 2080 Ti's, I've had pretty much every big card that there is, and this is about as big of a card as I've seen. It's pretty beefy. That Asus RTX 2060 Super that I had done a video on here a while back was a little bit bigger than this one, in that it was about 2.5 sockets, slots wide on the motherboard, but this is pretty good size. You can see this is probably take up 2.25 anyway. You probably won't be able to fit something next to it, and you probably wouldn't want to because it'd be blocking the fans, but good sized fans, very large. Cool. Those like 120 millimeter, I guess they're about the same as, pretty close, either 100 or 120 millimeter fans. I don't know how much noise they make necessarily, but big beefy heat sink inside there. You can see good amount of material there, should keep it fairly cool. But these are plastic shrouds. I've never been a big fan of that personally, but it looks nice. It's a nice looking card. XFX is not a bad brand from what I understand. I personally have, I think I only ever had one of their cards for a short while. I had an RX 580 that I sold to a friend of mine. I got it off Craigslist and then didn't end up needing it for anything. So anyways, should be a good card. This whole build should be pretty nice. So this is an AMD based build. We've got an AMD CPU, we've got an AMD GPU, Corsair memory, got a nice Gigabyte motherboard, we got our Inwin case. I'm ready to get started, and I hope you guys are excited. Here we go. Alright, so we got the motherboard out of the box. It's a pretty nice looking board, pretty clean layout. Like I mentioned before, there's one that looks to be a primary PCI Express slot, and then we've got this second one here, which is probably 4X. Hard to tell by looking at it. I haven't really bothered to read the board. We're not going to use it for this build anyway. But yeah, actually it says 4X on there. That's what I thought. 4X You get a couple 1Xs and you get your 16X here. You got your 1M.2 with a piece with a heatsink there, and then you get a secondary M.2 slot, but it does not include a heatsink. So if you were to use two M.2 drives with this, you would either have to go without for the second drive, or you would have to buy one to go with it. I've done a review here recently when I installed that Pioneer drive in my main desktop, where I got a different heatsink in that. I'm forgetting the name off the top of my head. I think it was Thermaltake was the name of the company, but you can get heatsinks for M.2 drives for like $10, not that expensive. So this is our AM4 socket, and what we're going to do here in a minute is take these points off. These are like the standard mount brackets for most CPU, like stock CPU coolers, but we're not using a stock cooler. And so, like I said, we're using this Cooler Master Evo 212, and what we're going to be doing with that is it's got the stock fan on it, but my my sponsor has asked that I replace this with the RGB fan here, and then also, of course, we're going to be putting RGB fans in the case for a total RGB look, as opposed to just having a non-RGB fan on here. Since this thing can actually support two fans, I almost think it would have been cool if he'd give me an additional fan. We could have done 8 and had a push-pull configuration on this, but this is how he wants it. This is the way he sells them, so that's fine. We're doing things the way that that the sponsor wants. It's the builds for him, and he supplied the parts. You can have it however he wants it. That's fine. But I'm going to have to take this fan off, and I've taken one of the existing RGB fans that he supplied, and you can see these mounting brackets on here. They came with the Cooler Master kit. They were in this little box that came in there with it, and you just take and you put a screw in each corner to mount them on there, and it just functions as a pair of clips. And I'll take the other one off, and then I'll just clip that on there, and it'll kind of mate to the side of the heatsink assembly there, and that should blow cool air through it, thus keeping hot air from building up around the fins. So another nice thing about this motherboard, while I got it out here, you can look at it, is this is a nice board that has a built-in I/O shield. I hate, like, that's one of the things that a lot of people will goof up when they make do a PC build, is they'll forget to install the I/O shield, and they'll get everything in there and realize that they forgot to put it on. I've done it probably once or twice in the past. I'm sure just about everybody who's built PCs has done that, and so it's like a common goof up, but an annoyance nonetheless that you got to take everything back out if you care enough, which it'll look kind of corny if you don't have the I/O shield. So this is cool though. Lately, that seems like they're all doing that. Most manufacturers seem to be doing that, where they just build it into the board, so it's not something you ever have to worry about forgetting again. But next step up here, I guess I'll go ahead and get these brackets off there, and I will figure out how to install this Cooler Master CPU cooler. Along, of course, we're going to put the Ryzen in there, the 2700X. We'll get our M.2 drive installed. We'll install our RAM, which I've already read in the motherboard manual says you can do either slots A1 and B1 or A2 and B2. So it shouldn't matter as long as I set up the way the manual said. Apparently you can do a lot of boards. It's like you have to do a specific setup if you're just using 2 DIMMs, or of course if you're using 4, you can use all 4 slots. But in this one, it looks like it's like 2 and 2 pretty much. You can do it how you want it. So we'll get everything installed here, and then we'll probably get the case up here on the table, and we'll start doing moving things into the case. Be right back. Alright, I hope it was fairly clear what I was doing there. I know I had to move the board around a lot and I was kind of fighting with it. It was sort of challenging to get these to line up, but these screws, like they're kind of a mounting screw of their own type here, but they have like this little plastic collar around them, like a rubber plastic collar that I'm sure is designed to keep it from grinding into the board and doing any damages to any of the circuit traces, so that makes sense. But the screw part on the other side of this, so like I'll flip this thing over here and you can see what I'm talking about hopefully, but it's sort of an irritation. But on this side there are the holes that it has to come through. Well, one side of the screw portion is flat, and so you have to line that up. It's like a, not crescent shape, but it's like more like half a circle. So you have to line it up just right to come through the hole on the other side while trying to keep that little rubber cap from falling off. And then you tighten it down with this, you know, these little nuts on this side. And then in the end, to tighten those nuts, they supply this little hex key, which can be used with a screwdriver like you saw me doing. And so you put this on each one and you screw it into place using the screwdriver. So, I mean, what should take a couple seconds is it's just an exercise in manual dexterity. But that's how that works. Hopefully that made sense. If anybody doesn't understand any of the steps that I went through on this so far, go ahead and ask in the comment section, and I'll do the best I can to address your questions. Next up, I'm going to go ahead and get this standard fan off, replace it with the RGB fan. I'm going to go ahead and install the CPU, and then I will go from there with mounting this Cooler Master CPU cooler onto the Ryzen 2700X. I'll install the RAM, M.2 drive, and then I should be able to probably put this in the case and continue on from there. You can see I did have to remove the original AM4 mounting hardware. I'm going to go ahead and throw that in the box that they came in so they don't get lost. But I'll be right back as I go ahead and start to install the CPU cooler. Okay, so for those of you who may not have done this before, we're going to try to do this as much as a step-by-step guide on building a PC as possible. So that for those of you, again, who have not built a PC before, or maybe aren't familiar with the different ways sockets are laid out, the way I installed that was first I raised up this lever arm here, and then that kind of shifts like the little socket for each pin on the CPU. Here, I'll take this off, you guys can see what it looks like. So you've got all these lovely little pins on this. If any one of them gets bent, usually that means the CPU won't work anymore. That's bad. So, like you see, you lift up the lever, or also called, like I think they call it a retention arm or retention bracket, put in your CPU, and then push the arm back down. And there's like usually a little outcropping here where it'll fit underneath that to keep it down and keep the tension on it. But you can see in the corner here, there's a little arrow. So if you look on the socket itself, there will be an arrow on the socket, a triangle in the same corner. So you need to have the corner with the triangle on the processor aligned, matched up with the corner on the socket that also has a little triangle insignia on it. That kind of makes it semi-idiot proof. So in case you don't know what direction to orient the processor, they've taken that guesswork out of it for you. So hopefully that's helpful, but give me a second here and we'll go ahead. I guess I'll show you what I did with the CPU cooler as well while I've got it here. So I've swapped on this KZYEE fan, RGB fan. We'll just call it RGB fan since I can't pronounce the name. And then this lovely mounting retention hardware here, which is really sort of irritating to get in there, but you kind of have to finagle it in here. And then there's like a little peg coming off the bottom of this. Let's turn this thing to the side here. So there's kind of a peg you can see in the center there. Actually, I think the peg is on here with like this little, yeah, and it fits into a hole in the CPU block itself. So the next thing that we're going to do, you need a screwdriver that's reasonably long here, but you can see actually the way that they build these heat sinks is so you can slide a screwdriver down it and still hit the screw, right? It's going to make some fun noises, but you can slide it down there and nail these to screw it into place. So you can take, well, I'm gonna try to demo this here. I gotta orient this in the right direction, sorry. Okay, now I'm not going to put it on there yet because I got to put thermal grease on the processor, but basically you can see that this is designed so that those 4 screws will mount and mate basically to those mounting screws that we put in there earlier. Oh, geez, this thing, okay, I'm going to have to put that fan on there after I'm done. This thing is like just kind of sliding on and off there. It doesn't get a real good grip on it for some reason. The one that was on there had a pretty good grip, but it seems like these ones on this aftermarket fan, like that, it's not getting a good hold. So I think it'll be fine once everything's installed and no one's trying to grab it and move it around, but as it stands, I'll just do it without that on there. So maybe it's a little easier to see anyway, but you can kind of see what I'm getting at. You can just boop, plop it on there. You screw each of the corners into place and you should be good to go. But like I said, I gotta put thermal grease on there first. And actually, there it is. They supply their own in the kit. This is Cooler Master. It's called Master Gel Pro, it says. I don't know if that's focusing very well. Camera's not focusing. This is my phone I'm doing this with. I was having better luck with this, but maybe you can read that. Well, whatever. It says Master Gel Pro Thermal Compound. You put some on the processor. It creates a layer of conductivity that helps the heat from the processor be conducted to your thermal cooling device, which in this case, again, is this lovely device here. But the heat is conducted through the aluminum block there. It travels up the copper pipes into all this lovely aluminum thinning heatsink material here. The fan blows through that and pushes heat away from it. It's also allowing it to retain a cooler temperature because heat is bad for electronics. We don't like it. So you can see kind of the way that this is oriented. We're going to put the cooler on here. There's going to be a fan on this side blowing air this direction. The back end of the case will be here with another fan designed to continue to push air out of the case. And that's like your exhaust fan area pretty much. Now the way that the Inwin 101 is laid out is over here. There'll be a couple of fans that'll be used as intake fans that pull in air from the back of the case. The back of the case on the Inwin 101 has kind of like a honeycomb design in it, but there's like slats cut into the back of the case that create, a place for it to draw in air. And so that'll pull in fresh air, comes in here, comes across the heatsink, blows out the back of the case, keeping your processor cool and keeping hot air from building up in your case too much. That'll also help exhaust heat from the GPU, which will be mounted here, and heat of course rises off of that, and it'll help blow that out of there. And also there's a bunch of cases that'll be, fans that'll be mounted on the bottom of the case in the Inwin that will help pull heat down, blow it out, and there's a little space between the bottom of the case and like the feet, and that should theoretically, as long as you have it on a flat surface and not on a carpet, you don't want to do this on a carpet, but have it on a flat surface to blow the hot air down, and it'll escape in all sorts of different directions. So you got a couple exhaust options, you have 2 inlet options, but again, we'll get that going here in a minute. But I just wanted to explain how the thermal dynamics of this is going to work, and I'll go ahead and try to get this thing installed. So give me 1 second to set the camera back up and we'll give it a shot. All right, you may notice there that it took me a minute to do that, and part of the reason was I got this corner tightened down too much initially, and then this one was raised up enough because the alternate corner was down so low that I couldn't get it down to the point where it was meeting the mounting screw point there. So I had to loosen up the other corner and then go back and kind of, so that they call it alternately tightening or alternately loosening. But the idea is you don't want to build up too much tension that like you can cause a bracket to break if you do like 2 sides on one side and they get all the way tightened down, and then you try to push it down to meet the other side, and you can't get it there, and you apply too much force and you cause damage. So the idea is to do a little bit on each, like this corner a little bit, that corner a little bit, da-da-da. You get them all started, and you work on each one of them a little bit alternately, so you never apply too much torque that causes you know, something to break. So it looks like it's on there pretty good. So I can pick it right up. So it's made good contact with the CPU. Doesn't appear to be oozing. I don't think I used too much thermal grease. I think I did an okay job there. Pushing the block down on it will cause it to spread out. That's why I put like about a pea-sized amount in the center, and then it'll just like little dabs around that, where pretty much just whatever was oozing out of the tip of the applicator again. But that being in there, that should smush that out. It creates, again, like I say, a film slash layer basically between the block and the processor. And maybe there's a little bit coming out the side there. You can see just a little bit of ooze. Maybe I'll get in there with some paper towel or something and just wipe the side so it's not gumming up things, but it should be fine. But I'll put this fan back on here, which pretty much just goes right on there. And again, I gotta get the RAM installed. I hope this fan isn't gonna block. Doesn't look like it should be, but maybe as long as I use the outer two, because again, the manual said that you have the option to use either or. As long as I use the outer two, hopefully, because this is kind of tall RAM. I mean, you can kind of see what I'm getting at here, but it's fairly tall memory DIMMs. We might, I might get with them and get a different set of memory if this doesn't appear to be, you know, a good option, but I think it'd be all right. Give me 1 second, we'll try to get that done. All right, so we're gonna go ahead and install our memory modules here. And so we're gonna go with A2 and B2. That'll get as far away from this as possible, so hopefully the fan doesn't bump into it. But as you can see, there's like a little notch in just slightly off center in the pins there. There's 288 pins in a DDR4 module, and we're gonna go ahead and slide that into place. You open these little retention clips on the end first, and you should be able to push it into place, and you should hear it click when you're done. And that means it made good contact and it's in there. Do the other one here. Some boards, they'll reverse it, like depending on the channel layout. So it's like this would be channel 1, this would be channel 2. And they'll have like the notch reversed, and the DIMMs will be in reverse orientation from one channel to the other. This one looks like they're all laid out the same way, but that's something to watch for, so you don't end up trying to jam them all in the same way and end up breaking the memory module or messing up your motherboard because you didn't notice the notches were in the different, you know, a different orientation. So just something to watch out for there. Voila, memory is installed, dudes. Let's see if this wants to go on here successfully. Maybe I can try to do it kind of. I don't want to bend up this set of fins. Sort of. Let's see here. Yeah, I don't know. That's a tough way to go here. Hold on, let me see here. I'll just sit down what I'm doing here. Try to be careful here with this. I don't want to damage this thing, but you can kind of see where it's butting up against that memory module. This is sort of a pain in the neck, but we got wires that are in the way here. There we go. Those are out of the way. There we go. All right. Slip this down here just a little bit. All right. Cool. I don't want to touch that anymore. But as you can see, if I put these on the, well, there'd probably still even be room. It'd be close, but let me come back here. You can see. So, I mean, there's a little space, but it'd be tight. I think with just 2 modules are probably good. Or again, if the person who buys this machine wants to upgrade their RAM in the future. I mean, it's 32 gigs. They're probably not going to need more than that at any time that I can think of. But, you know, and maybe they're a workaholic type person who runs a bunch of different applications and needs 64 gigs, whatever. I think they'd have space, but it'd be very tight. Or they might want to go with, like I say, a shorter module that could be underneath the fan, and then it wouldn't be such a big issue. But that's installed. Memory's ready to rock. That's ready to rock. Next, we'll do our M.2 drive. Let's do that. Get that ready to go. All right, so there's our little Western Digital Blue 500 gig NVMe SSD. You can see the M.2 interface there. This is a PCI Express driven drive, so it uses 4 3.0 PCI Express lanes provided by the CPU and or sometimes the chipset, depending on if you use Intel or AMD. Different boards, different chipsets have, different chipsets have different layouts and provide bandwidth in different ways. But in this case, this is probably, I think with the X570 chipset, well, again, this is a 2nd gen Ryzen chip, not a 3rd gen, so it's going to provide 3.0 lanes. I think there's usually 24 provided total, or maybe it's 20. With Intel, you get 16 on the CPU, and usually like the board will give you 4. It varies a little bit, but we should have enough, I think, to run the GPU at 16x, run this at 4x, and then I think the South Bridge provides bandwidth to the SATA controller, which would provide bandwidth for the the one SATA drive that we're going to use, the Seagate over there. So shouldn't need any more bandwidth than that. Hopefully everything can run at their maximum potential. That's what we want. We don't want things running slow. So what we're going to do here is we're going to get this little heatsink removed. We've got like a little screw that retains that there. This will pull out and come off there. And there's probably some thermal kind of adhesive underneath it, or create a layer to help cool the chips on the SSD, because these things can run pretty hot. They run very fast, and as a result, they get pretty warm. So let me grab a little screwdriver here. That's right, I'm working left-handed. I can do both sometimes. Okay, so that's removed from there. And like I thought, so we've got this little blue thin layer that's like a protective adhesive layer, but once I take that off, the gray padding pretty much performs the same function as that thermal greaser you just put on the CPU. So we've got that removed, and you can see here the M.2 socket is in there. It looks just like this one here, but this one's got a little bit of metal armor plating over the top of it to help retain that heatsink on there. And you can see that there's no current, these are all empty, because they don't know the length of your drive that you plan to use, so they supply you with 3 different possible lengths, and you put this little screw in here, little mounting screw, wherever you need it. In my case, it looks like it should be there. I'll put that in there, and then you use this screw that screws into this, and that will hold the SSD in place, and then I'll cover it up with the heatsink, and then screw it back down with that heatsink back down over here, covering it up and protecting the drive. So let's go ahead and give that a shot, shall we? All right, if anybody has any questions about how that went together, then please go ahead and let me know, but I think I got it pretty good with the camera. And as you can see, that's now pretty sturdily protected by this lovely little heatsink that they supplied. It even kind of matches up with the little paint design that they've done on the motherboard here, so it all kind of ties together nicely. Got our heatsink set up, we got our RAM installed. Next thing up, we're going to put it in the case. Once it's in the case, we can get the power supply installed. We can install our little RGB fans and our lovely little XFX 5700 GPU. Stay tuned. All right, here we go. We've got our case out of the box, and these are the little accessories that come with it. They sort of give you some zip ties, and this is the Inwin 101 case we're working with. And we've got, like I said, some zip ties. I'm not sure what these little rings are for. They might be for putting around screws or something to keep them from damaging the motherboard. Not quite certain what those are for. I think this is like a video card brace. That's a guess. I'm not actually sure. I'd have to find the instructions for it. It's not really necessary for anything that we're doing, but it comes with a bunch of screws and little stands here, and these are what the motherboard gets mounted on in the case. So this is the case itself. See me in my reflection here. Not much I can do about that, but again, this is the Inwin 101. This is the black version. They do make a white version of this case. I think that's the only 2 colors that it comes in. And they've got these cool little knobs on here to open this out, which is kind of nice. You don't have to screw with anything else. You don't have to take off any screws or anything, but this is tempered glass, so you gotta be careful when you mess with this. That could be easily damaged. Expensive to replace. Probably have to just get a different case. I don't know that the manufacturer would send you another one. So this is the interior of the case. As you can see, the little mounting points here are not installed yet. That's what was in that accessory box. So you have to install all the little stands yourself, and then you can mount a motherboard in here using the supplied screws that will then connect to the little mounts that they gave you. But we've got, I think I mentioned earlier, like this is the intake section for the air that's going to come in. So we're going to put 2 fans in the back here, 2 of these RGB fans, and they'll be blowing this direction inward, which sucks in cool air from the outside of the case. And then I'll be putting 1 RGB fan on the back here, which will blow air out of the case. That's exhaust. And then the bottom supports up to 3 more fans, which the gentleman that set me up with these components would like to blow downward. So that's what we're going to be doing for those. And that should theoretically cause air to kind of escape out the sides, out the back of the case, etc., if it blows it down. And since the GPU is going to be mounted right here, hot air from that's going to blow down. It should kind of pull hot air away from that and blow it out the bottom of the case, theoretically. That's the way that we're going for it. That's what they want. That's what we're doing. We've got 2 hard drive bays up here, which you can just open up, and you should be able to put in a 3.5 inch standard hard drive, which is what we have with that 2 terabyte Seagate. And if you pull this out, you can see that there's 4 little mounting points here, and you can put a 2.5 inch drive on those by screwing it in from the bottom, and that's for solid state drives. Or like you could use a laptop hard drive in here if you wanted to, but for the most part, it's for people who want to use a solid state drive that isn't an M.2 style. So like the one that we used, that we put in here, is M.2, but they make 2.5 inch drives that use the SATA interface that you would mount on this if that's what you were going to use in your system. We are not, though. So let me see if I can get this to go back in here. I'm sure this will be interesting. Actually, I probably should just leave it out. I gotta put a drive in it anyway, but yeah, I gotta, oh, there it goes. There's like a little edge here that catches on. So you gotta put me on the edge, and then it clicks right back into place. So that's the front of the case. The back of the case, I don't know if I can turn this around too well, but I'll show you the front here actually. This is the power button up here. I have the same case myself. I use this for my capture PC that you guys may have seen me do a video on in the past with my Avermedia capture card and so forth. So I've used this case before, pretty familiar with its layout and how to build in it. But just like I said, this is the little power button here, and this section should be controllable by the RGB software of your motherboard if you connect the case's RGB header. There's like a little 3 or 4 pin. I think that these are standard RGB. So to explain RGB, actually I can show you guys on here. We've got 2 different sets of pinouts. This is the 3 pin, this is the 4 pin. This is addressable RGB, which is digital. This is analog RGB, which is analog, sorry. The standard RGB, sorry, is analog. And it's, so 4 pin 12 volt, 3 pins is 5 volts. Not that you necessarily need to know the voltage on this, but that's just a little blurb piece of information. But, so this case should have a 4 pin, I believe, which would run somehow to this, and then the motherboard's software. So again, this is Gigabyte. They use what's called Fusion 2, 2.0 rather, which is what they use to control any RGB devices connected to the motherboard. You should be able to change the colors of this using the Fusion 2 software from within Windows. So that's what that's for. Give me 1 second here, I'll turn this case around, we can look at the back of it. All right, you can see in the back, as I mentioned, there's like a honeycombing effect here, which allows air to pass through, and thus the fans that are going to be mounted on the other side are going to pull air through, and that's our air intake section. I think they put it back there just so like it's a little bit hard and you can't really see it. That's like the whole purpose of a lot of the things in these cases, to hide wiring, hide different things, so it's like everything looks pretty clean. These are supposed to be thumb screws, but I gotta admit they're on there pretty good. I may need to use a screwdriver to loosen those up. Give me 1 second, I'm gonna get the back panel off and we'll look at the back end and how you can do cable management in this thing. All right, so we've got that back panel removed, and you can see back here, like I said, the fans will mount on the other side of this, but these are all little screw points where you'll mount your various fans. This can be removed out so the fans can be put on it, and then you can put it back in and screw it into place with these screw points right there, here and here. You've got some wiring here, so you've got like your wiring for the power switch, which again, like I said, is right there. I don't think this case has a reset button, which is sort of weird, but like I say, I've got one of these myself, and I don't recall ever being able to hook up a reset switch on it. It does have two USB 3.0 ports here, and one of these is going to be the headphone, one of them is the microphone jack, but they're not labeled, so I don't know which is which. You just have to figure that out once you have it hooked up, but it does not show that. And they've got some wiring here. Okay, so yeah, like I'd have to undo some of this stuff. I'll show you guys some of this stuff in a minute, I guess. I was gonna say down here they've got an additional place to mount a solid state drive. So if you didn't want to put it up here for some reason in the tray, you can mount an SSD down here on this plate, which, like, you take this thumb screw off, you take this little plate off of here, you mount the drive physically to these four corner holes, and then you screw it back into place on here, and then that way it's totally out of sight. And then you probably would route cabling from it like around here and up to your motherboard SATA ports, but that way most of the wiring would be retained behind back here, so not so much to see. And there's a second spot right here, same deal, which looks like this is also removable. And so you have basically you have room for 4 drives in the system total, not counting M.2 drives like the one we put in the motherboard. So you can put 2 3.5s or 2 SSDs up here, whatever you want to do, and then put 2 2.5-inch drives down here, whether they're SSDs or like laptop hard drives or whatever it is that you're using. You've got room for that. So those are nice. These little points here are for cable management. So you can lace like a zip tie or a twist tie like they've got here through this, and then you can use it to cinch down wiring on the back. So once again, like if you want a clean looking build and you don't want wires flopping around willy-nilly, for lack of a better word, you try to route them as best you can. Like for the fans, for example, you can route, you know, fan cables back through here. You can tie them off to this point, or I think there's, yeah, actually hard to see, but you can, yeah, see there's like a hole here. You could route like the power cable from the fan through here, and then you could twist tie it off here, or whatever it is that you wanted to do. So you have lots of those little points. That's not it so much. Let me see. So you got 2 here, 2 here, there's 1 up here. But in general, you've got a lot of places to do cable management if you so desire, which we will be doing a lot of that. And then finally here, we've got the the power supply bay, where you can slide in the supply up here. The fan for the supply faces down and allows it to blow air downward out of the fan, and then it'll exhaust out the back. But that's nice that they put a hole in there for that, because some of these things, it's like the stupid supply is covered, and if the whole thing is covered, it's like, where does the air escape to? But there's 4 points in the back. You screw the power supply into place up there, it stays up here, and they have a nice amount of space in here so that your cables from the power supply are not like kind of just jammed together or whatever. You've got some space for them to sit in here, and so they're staying out of the way. With a modular supply, you wouldn't need that quite so badly, but with the supply that we're using, it is not modular, and so we're going to have a nice amount of space here to just set the extra cables that we don't need. What we're going to need is we're going to need a cable for the CPU. So this is the 8-pin CPU power connection. We've got the 24-pin 12-volt power connection over here, and that should be it from the power supply directly to the board. But there'll also be, if we're going to have a 3.5-inch drive, the Seagate drive, which is going to be in here, we'll need there'll be a SATA power cable that will run from the power supply over to here, and then it looks like some other cables are on here. Yeah, okay, so like for example, this is a power cable that will have to be connected to the power supply, which lights up this, as I recall. I think it supplies power to like these buttons and so forth, but the lighting up here is giving power through that connection. So give me a second here, let me untwist these, and we'll go over what some of these cables are for and where they connect to on the motherboard, so you guys get a general idea of what you'll need to do with these. All right, I got that twist tie off there. So this right here is a USB 3.0 cable that will connect to a header on the motherboard, which we've got. Okay, so here it is. So this board actually supplies you with a couple in case you have additional ports on your whatever case you go with, but this one only has the 2 in the front, so they've got a single header here. We've got, like I said, this case doesn't have a reset switch. I was right. All it's got is a power switch and hard disk drive LED light. So basically, when your drive is being accessed, this having this plugged in will cause there'll be a light somewhere on the case. I think right here, probably this little hole, there's probably an LED behind that, and it will flicker on and off as your drive has access to that. Lets you know that the hard drive is getting used, which is sort of useful in troubleshooting if the drive isn't working or is for some reason like it's frozen up and it doesn't come on. You kind of know that maybe something isn't right, but that's helpful. We've got a HD audio cable. So this again supplies a connection for our microphone and headphone jacks, and that will go down here to the F audio or front panel audio header. So now this looks similar to these, which is front USB 2s, but the little pin that's missing is in a different location. So in here it's in the upper corner. Here it's one away from that. So don't confuse your front audio for USB and try to jam it in there and bend a pin or damage something. That would be bad. But this case doesn't have front USB 2s, it only has the front USB 3, so this is the only thing we'll be using is one of these. And then the final portion of it, the cabling that was offered here was, again, this is the SATA power connection, which will connect to the power supply. And then here, okay, so as I mentioned, this is a analog RGB. The difference between analog RGB and digital RGB is the amount of colors it can display simultaneously. So if you have analog RGB, like this front panel here could be green, or it could be blue, or it could be red, but it can't be multiple colors at once. So it can transition between those colors relatively smoothly and it'll look nice, but it will not be able to do like a rainbow effect, for example. Like a lot of more modern fans are capable of being rainbow colored. This will not do that. This will do one color, then another color, etc., if that's what you want it to do. Or it can display a static color, or it can do some of the effects like breathing that they call it, where it's like it fades in and comes back on, fades out and comes back on. That's called a breathing effect, and it should be able to handle that, but it can't do rainbow effects or like swirling colors or something all at one time in this little Inwin crystalline plastic thing here. It'll just be red or blue or whatever heck it is. And that should be it for this. Like I say, that's the power connection to the power supply. This is where it connects to the motherboard so that you can control it using your RGB software, in this case Gigabyte Fusion 2.0. So I hope that that's been a good explanation of how all these different things work and where they connect to on the board. If you do have questions about any of this stuff, be advised you can ask in the comment section. I appreciate any comments or questions that people want to leave. It helps the channel in the YouTube algorithm if you ask questions, so please do. But that said, I guess what I'll do next is I'll get this motherboard installed, and we'll probably put in the video card and the fans, and then I'll try to do a nice wiring job so all this stuff is well, kept back here and, hidden off the side or something, and twist tied off so it's nice and neat. But here we go, let's get started. Okay, so I've got the little stands in here that are started in the corner here. We got one here. This case comes with some of them pre-installed, like there's pre-posts already in here for a few of the locations. So you just pretty much have to look at your board and figure out which ones of these apply to you and put posts in accordingly. There's two that I actually didn't need. It came with 8 and I only needed 6. Like I said, the other ones seem to be supplied for. They've already put them in, so I don't need to do any more. But that's what's called ATX. If you have an extended ATX board, which is longer, you'd use posts further out. And then they have other sizes, like there's micro ATX, which is probably in here, and then ITX, which is very small, probably just fits on these 4 corners, I think, and maybe just goes a little bit further than that. I don't really know why you would put a small board like that in a larger case like this. They make nice small ITX cases that are really cool looking, actually. Like Inwin, in fact, makes some that are really nice, but in general, I don't understand why you would, like I said, go through with getting this large case and then putting a tiny board in it. But if you happen to have that board lying around and just need to throw it in something, they make it so it's pretty universal, forward and backward, with a lot of different things. I'm surprised that this has room for an extended ATX board, because those are usually quite large boards, and usually that will only work on a full tower. I'm pretty sure this is considered a mid tower. So they make, ITX towers, they make micro ATX towers, mid towers, which is pretty much your standard size of PC. You got a full tower, which is larger than that and usually allows you to, like I say, install extended boards. Things like that are usually also, like, if people want to do crazy water cooling setups, you need to have a very large case that can fit like a radiator or several radiators sometimes. And then like they'll have a reservoir for the liquid and pumps and things like that. They got all these different things that you need. You need more space, so you gotta have a bigger case. And then they even make what they call like a super tower. I've seen a few of those. There's a company called Cougar that makes one that you can build 2 PCs into at one time, which actually I kind of wanted to do at some point. Would be kind of cool, because then I could have like my main gaming PC rather, in the same case as my capture PC. Then I could just run like a little HDMI cable from one to the other, and then you can capture your video without having to have 2 separate PCs and drag around 2 different systems. But it's a really huge and heavy case, and I imagine that having 2 PCs with all their hardware in that giant case would be pretty hard to move anyway. But anyways, I just wanted to show you guys how this is laid out. Like I said, this is an ATX form factor. ATX, I should know what it stands for. I should have looked it up before I did the video. I don't know what it stands for, but it's the standard style of motherboard is what that basically means. Like the IO shield will face this way. They have what's called BTX as well, which is reversed, and like the back of the motherboard will be facing the front, like what we consider the front of the case. It's just done in reverse for some reason. Dell, HP, Lenovo, some of these companies that do systems will sometimes use that. And then they even have like inverted cases sometimes where like the motherboard's upside down, you know, like it'd be an ATX board, but it'd be upside down and everything would be like down here, but that'd be the front of the case, or like things are oriented funny or backward. It's a lot of companies do things in a unique or abnormal way, but just to try to be different probably. But I'm gonna go ahead and start putting in the motherboard here and so forth. I still got to tighten these down. It came with this little thing, which is kind of cool. This is kind of like what came with the Cooler Master. Not focusing well with the camera, but anyways, it fits over these, and you can use it to tighten them down, and you can even use a screwdriver, just like with the Cooler Master. You can use a screwdriver on this to tighten it down fully, but you can really do it by hand pretty well. You probably don't even use a screwdriver, but you see the idea. Those are installed there. That's what the motherboard will sit on, and then we'll screw the motherboard into place using the supplied screws there. I think what these are for, these rings, is probably to sit between the board and like the lip of the screw. It just makes a little cushion and probably prevents possible torsion or damage, that sort of thing, to the board. So that's what we're gonna use. I'm gonna go ahead and use them. They came with it. I'll go ahead and use them. But be right back here. We're gonna get started. All right, you can see we've got our board in there nicely. All our screws are done in where they should be. Strangely enough, it didn't come enough with those little like washers for every screw. So there was like 2 or 3 where I didn't have one for it, but everything else got one. So that's in where it should be. Everything's looking pretty nice. Next thing up, I guess I probably install the fans, because I don't want to try to put the video card in until I get the fans in there. It's a really, it's a very large video card, and I feel like that would sort of get in my way as I started to try to do other things. So I think the next thing we'll do is the fans, and then after that I will try to go ahead and get everything kind of connected up. I'll probably put the video card in last, just because, like I say, it's so large. I don't want it to get in the way when I'm trying to, like, connect the SATA cables or anything else, just something to keep out of the way. But we'll get on that next. All right, I think I'm just, for the sake of saving time here and recording space, I'm going to go ahead and just do like one of these fans on video, and then I'll just go ahead and install the rest of them, because it's pretty straightforward. You can see there's mounting points here, 4 in each corner for screws. Like I say, back here there's going to be one more that again will have room for screws. You could also put like a 120mm radiator there if you happen to use water cooling on your CPU instead. that sort of thing. In fact, like I think that's what I did on my capture PC. Or you could even put like if you had a bigger radiator, like this is, you know, that mounting point that was back here, you could use like a 240 millimeter radiator and mount it over here and have air drawn through that. I don't know if you'd really want to do that or not, how like that'd basically be drawing in cool air to immediately cool the CPU, but then it's like it really wouldn't have anywhere to go. It would take it a while to travel over here, may not be that effective, but yeah, you get the idea. You can mount radiators there, you can mount them back here, you can put one on the bottom, but that'd be sort of a questionable place to put it. But you have options. You have many, many options here. But like I say, the way this is gonna work is I'm just gonna mount a fan on here, a fan on here. They get screwed into the back. These are the style of screws that you will use for this kind of fan. Each one of them comes with 4 screws in the box over here, so I have enough screws to do all the fans that I was supplied with. But on the back there's places to mount them, and then I'll put it back in the back there. And like I say, one way to tell the way that the fan's blowing is whatever side the grate is on is the way that the air will blow. So if you're unsure and you're looking at it and you're thinking, oh, this is surely, no. If you want the air to come this way, you need to face the grate in whatever direction you want the air to blow. But that said, like I say, installing this is pretty straightforward. I don't think there's any really need to show you guys how to put in 4 screws. They go into each corner, pretty straightforward. Once that's done, I'll try to start getting, I guess I'll put in the power supply for that and start wiring some things up, like in connecting the case power switch. I gotta put in the hard drive still. We gotta hook up the SATA cables and so forth. So those are things we can do, but I'll be right back. And you can see those turned out pretty nicely on there. And they'll pull in air from the back of the case, supplying cool, fresh air for the system. All right, moving along here, I'm gonna install these and go, like I say, put this mount back into the case, and then go ahead and put the fans in the bottom and the one in the back of the case for the exhaust fan. Go ahead and do that and be right back. All right, I had to go ahead and install some of these cables down here before I go ahead and get the fans in, because once I get the fans in there, it'd be damn near impossible to reach like these different headers. So this is the front port audio header that we talked about. So that's connected. Over here we've got our USB 3 connected. And then here you can see I've got the, well, this is hard to do with the phone zoomed in, so I apologize, but it's going to be hard to see the lettering on it, but you can kind of see, which is like power, LED, and things like that down there. Hard drive, it says RVS for reset, switch, etc. They're all labeled underneath it. It's just difficult to see it from this angle, but up here on the top is I believe that's the power switch. And anyways, in the bottom is the hard drive LED. This case doesn't offer anything else, so there's no need for a reset switch. There's no any other buttons of any kind that this case offers that would need to be connected here, but they give you a lot of different options because some cases have more switches and connections than this particular case has. So right now I only had to connect 2 of them, but often you might have to connect quite a few more. But anyways, I just wanted to show you guys that, because like I say, after this I'm going to go ahead and put the rest of the fans in. I've got these 2 here in the back. Let me zoom out here. I've got these 2 here as we showed, and then I've got the one in the back. But like I said, the ones in the bottom will basically be kind of blocking some of these cable accesses, and it would have been difficult, if not impossible, to install some of these cables with the fans in the way. So that's why I did that. But I'll be back in a minute. All right, we're making some pretty good progress here. We've got all our fans installed. They look pretty nice. They all spin as they should spin, I think. Yes, indeed. Spinning, spinning. Intake. Exhaust. Exhaust, exhaust, exhaust. And this one will keep our processor cool, coupled with pulling hot air out through this one. So that all looks pretty good. I got the cables routed pretty well here, so they're not too visible up front. I'm trying to tie them off in such a fashion that they're pretty much invisible, you know, like from a straight-on view. And then in the back, we'll practice some good cable management after we're done with this. You know, at the end is when I'll start screwing around with that once everything else is installed. I guess the only thing else left to do is put in the hard drive, the power supply, get everything pretty much wired up, and then get in the video card, and then do with the cable management. So we're making pretty good progress here. I'll go ahead and start on that here in a minute. Be right back. All right, we got the power supply out here, taking it out of the bubble wrap. I say this is not a modular supply. What a modular supply means, for those of you who aren't familiar, is there'll be a bunch of sockets on here for the different types of cables that the power supply supports, but it won't have any cables actually plugged into it. They'll come in a separate bag, usually in the box, and you can take each one out and just plug in the ones you need, so you don't have all these extra cables here in your case for things that you're not even going to use necessarily. So like we'll go over the different power connection types here in a second, but basically, like I say, that's what a modular supply is for and why they're kind of considered to be more desirable for cable management, because you just have less cables to manage, and it helps with airflow in the case, depending on the case. This case, actually, I don't think it's really going to matter much, if at all, because of the way this case is set up. Like I'll show you here in a second what I'm getting at. I think I mentioned this earlier, but like I said, this case is set up wherein I can just kind of stuff those cables up in here, and they're not going to get in the way or hurt anything, so they're not really a big deal. But on some cases that don't offer the kind of backward enclosure area here where you can hide something, you know, it's more detrimental in some cases than it is in others. So there's that. But this is a 700 watt supply, which should be more than enough for this system. This XFX card, I believe, takes 250 watts, I'm guessing. I can try to find that out for you guys. I'll try to include some information on the screen as I do, you know, once I go in to edit the video, I can try to add some of that sort of stuff, like the different specs of things. But most of these AMD cards, I believe the 5700 XT uses like 300 watts, and this is the standard 5700X. If it's an overclocked version, sometimes they use more power out of the box than not. Overclocked means that like all these cards have a stock speed setting, which they call like the core clock or the memory clock, depending on if you're talking about the actual chip itself. The little GPU processor, their graphical processing unit, runs at a rated speed for whatever model it is. And then they also have video memory, and that has a certain speed that it's designed to run at. Overclocking means that you can increase those frequencies to run at a higher rate and make the card run faster. The detriment to that is that it will cause more heat. If you go too crazy with it, you can damage the card, or it can reduce the card's lifespan if you do a lot of that and you have it running at like an exorbitantly high speed all the time, you know, and it gets too hot. The offset to doing that is you need to use an advanced cooling solution that will keep the card at a lower temp and allow you to keep those high frequencies without damaging the card. This cooler is a stock the stock coolers for these are what they call like a blower fan, where it'll have like one little smaller fan down here, and it will just blow the air out the back of the case. This is not a stock fan. This is again, this is like the XFX Ultra series of this variety. There's a bunch of different kinds of fans, a bunch of different kinds of graphics cards that all use different cooling solutions based on the manufacturer. Most of them end up looking pretty similar to this, with two fans on it, you know, varying sizes or whatever. Again, like the stock ones, usually they call that a reference design, and if it has a blower fan, like it'll blow, you know, like I say, the air out of it. Reference design just means like the original design from the manufacturer. So AMD created the you know, the RX 5700 and 5700 XT, and when they created those designs, that was called the reference board. And then you get non-reference designs from manufacturers that want to make their own additions to the card afterwards. So, for example, actually, I'm not really that familiar with AMD's non-reference designs for the 5700 series cards, but just a different example would be like for the 2080 Ti, you can get, you know, like a standard 2080 Ti from NVIDIA called the Founders Edition. You can then get from EVGA, for example, which is another manufacturer that makes video cards. A non-reference card would be like their for the Win 3 edition, they call it, which has more what they call power phases, and it has more circuitry, basically power circuitry that allows the card to be run at higher, accept more power. So, like for example, this card has got an 8-pin and a 6-pin PCI Express power connection. That card would have two 8-pins. Some of them even have like 3 8-pins, so you can add more power to the card. It can handle the additional power. Usually they have fairly aggressive cooling solutions. Sometimes they have like a 3-slot cooler, or a lot of them just come with a water block for water cooling. Some of them have what they call hybrid cooling, which is like using an all-in-one CPU water cooler, but they put it on a video card. I've done videos in the past, if you look at earlier on my channel, where I've done that on my 2080 Ti video cards, where I've installed both all-in-one aftermarket coolers and also like what they call a hybrid kit for the EVGA 2080 Ti to better cool those cards. Because stock, they can get up to like 70 or 80 degrees. With a water cooler like that, You're looking more like idling around like the high 20s to low 30s, depending on the ambient temperature of your house or where you live. But they may get up to like the 50s or like maybe 60 degrees tops, you know, under like extreme usage scenarios, like, you know, you're playing a game for a long time and it's kind of hot in the room sort of thing. But this time of year where it's fairly cold, it's, you know, they'll run really good and chilly. But anyways, hopefully that wasn't too long of an explanation about video cards and power supply and whatnot. So let's go over the connectors on the power supply. This is again like a 6/8 pin PCI Express power connection, so that's going to go to the video card. They have these additional 2 pins on here, so you can make it an 8 pin if you want, or you can make it a 6 pin, so that's handy. There's 2 of those on a line together. I am going to do what is called load balancing if this power supply allows me to do that. Let's see if it's got, it should have a second thing to use here for video card. I don't know if there's a second one on here or not. There may not be. Okay, well, we'll see how this works out. AMD cards use a lot of amperage as well as a fair amount of wattage. And if you use a single line like this is all on one line tracing back to the power supply, sometimes you don't get enough amperage across the cable like this to go and use, like, again, we saw that we need an 8 pin and a 6 pin. So like this would be 8, this would be 6, and you hook it up to that, to the card on this one line. It may not get enough amperage from that. I've used cards in the past, some of AMD's previous generation cards, they had what they called the Vega series. They had the Vega 56 and the Vega 64. And those cards, when I first got them, were very buggy and would die out, or I don't want to say die, but like you'd get aberrant system behavior like black screens or blue screens, or just hard lockups and weird issues like that. When I did what's called load balancing, which is instead of running one line like this, you'd need a separate line. So you do like 8 pin on this line, bring out a totally different line, 6 pin. That way you're splitting the amperage usage across 2 lines instead of one, and that can increase the stability of the card. It's been my experience with a lot of more recent AMD cards that you kind of almost have to do that. So this power supply, I'm going to look and try to find a second PCI Express connection on it, but it kind of looks like it may not have one. And if it doesn't, then I'll look it up. It'll work or it won't work. But that's just another thing to keep in mind later if you guys purchase any of these higher end AMD cards like this. Load balancing them is usually a good idea. So this is the CPU 8 pin power connector that's going to go and give power to the processor. This is the 24 pin 12 volt EPS power connection. This will just basically generally supply power to the motherboard in general, so you know it'll supply power to all the lights and all the little fan headers and so forth, so that's what that's for. There, we already went over the PCI Express. This is called a 4-pin Molex power connector. These are getting pretty old. You still use them occasionally, but they're not nearly as prevalent in systems as they used to be. They always come in the power supply because people use them for certain things. And some stuff like fan controllers and other things, they used to use them for hard drives. So like the older IDE hard drives that they used to have that were on those big fat ribbon cables, this is the kind of power connector that you used for those. But again, like they're still used, but just not as much as they used to be. But again, like they still give you this would be like what they call legacy connection, which means it's kind of outdated, but they still give it to you in case you need it. This is even more legacy. This is a floppy disk drive power connector, which, I mean, again, like you can put a floppy disk drive in your system if you want. There might be scenarios where you'd find that useful, but they're, you know, those scenarios are getting fewer and farther between, but they still give you the connection just because you might need it. And actually, this power supply is a slightly older model. I mean, it was new in the box, but this is like, well, you're talking about, it says it was supporting the Haswell series of Intel CPUs. Haswell is 4th generation Intel chips, and we are about to go to the 10th generation right now, so that might give you an idea that this is a slightly older model. It's still a good power supply. It'll be fine for this. Like I say, it's new out of the box. It just, it's definitely a little bit older. I actually don't know 100% sure if the brand new like power supplies you're seeing come out will have floppies or not. But again, it's like most of the ones that I've used are modular rather, so you would have the option to use it or not. But in this case, it's just part of this big mess of cables. Here we go. One last thing here. This is for a SATA. This is a SATA power connection. So on the back of a hard drive, you're going to have 2 connections. One of them will receive this for the power to power the drive. So that hard drive that we're using, this 2 terabyte drive here, which I'm going to put in here in a minute. Well, I don't know if you can see it through the bag. You can kind of see it there on the left. It's reflecting again, but on the left there you can see like that larger kind of long piece of plastic there. That's what that will connect to on the power supply. And then the other connection to that drive will be, well, these are kind of stuck together, but you get the idea. Okay, these are SATA cables for the data transfer portion of the drive. So these are what you'll use to connect it to the motherboard of your PC, and that way Windows will detect it, and your BIOS will detect it, and so forth, and then you'll be able to transfer data between the motherboard and the drive, and different drives on your system, etc. So I think that's pretty much a good explanation of what the different cables are for in the power supply, the different connector types. If there's anything I didn't go over or anybody has any questions, please be sure to leave a comment in the comment section and ask, and I will be sure to answer as soon as possible. I'm pretty good about responding to people asking questions on my channel, or at least I try to be. So I guess what I'm gonna do next here is go ahead and get this installed, and we'll get the hard drive in there, and then I'll kind of wire things up, and lastly we'll put in the video card, and then I'm going to work on cable management, because as you can see we got a pretty good rat's nest going on here. I need to also take, where's this at? I need to take this right here, which is the RGB controller that was provided in that box from KZYEE, I think is how, again, I'm probably pronouncing it wrong, but they spell it very strangely. So you can see on here we've got all these little connectors here. It says they've got some for fans and some for LEDs. I'm not really sure what these kind are for, but I think I know what it is. Like they make splitters to do like LED lighting strips, or like that, like the connection for the LED lighting strip. I think that's what that is. It's a type of 4-pin, but it's not the same thing as the 4-pin RGB header on the motherboard. It's different, but it's still 4 pins. But these other ones here, this is all proprietary. Like these kind of fan connections here are probably strictly for this company, KZYEE. Like you probably wouldn't be able to take fans from any other manufacturer and hook them up to this. They like to be proprietary with their stuff, so you got to use their fans with their controllers. That's of course just a sales tactic. And then this is a little remote control that comes with this, so you'll be able to control the lighting, while you're sitting away from your PC, and you can shut it off, turn it on. You can change the colors and cycle between different kinds of coloring schemes and like patterns and so forth of lighting using this remote. So that'll be kind of cool. Some PCs, like again, I think I mentioned earlier that this motherboard is from Gigabyte, so they have what they call Fusion 2.0, which is RGB software that will be run from Windows. This is going to be separate from that. So for this particular PC, let's see, things that will need to be controlled by Fusion would be the RAM, and like any lighting that this board may have. I didn't really look that closely at the front of it, but some motherboards, like the motherboard I have in my main desktop, is called an MSI Meg Ace board, and it has what's called like an infinity window, which is like this little pattern area that shows lights moving and doing different colors or patterns depending on what you select. That's controlled from within Windows. So this one, I think the only thing that will need to be used for the Fusion software would be the RAM, and possibly, again, like if there's any lighting on the board, there may be a couple little sections that can light up if if you so choose, and that would be done through Fusion. But everything else should be controllable. All these fans will be controllable through this using the remote. All right, hopefully that's a good explanation. I'm going to go ahead and install the power supply, hard drive, etc. Let me know if you have any questions. All right, I don't know how well you can see in there, but I've got that 8-pin CPU connection down in there, and then the power line from that is just running up through the top. back up into that hidden area up there. And then this is the 24 pin, again coming from the power supply, curving around here and connecting to the motherboard. So those are two main power sources that the motherboard needs. And then I've got the power cable for the video card hanging out here, because that's going to have to connect. It'll be somewhere around here in this physical area once that the video card's been installed. So next thing up here, I've got the hard drive, which, as we mentioned a minute ago, so you can see on the left hand side here, we've got this large connection. That's for the SATA power connection, and the one, the smaller one on the right of it is the one for the SATA data cable connection. Those extra pins there, you know, they used to have what they called master and slave drives. So like when you had an IDE drive, you had to set, like, one is the master drive, i.e. that would be your primary drive in the system, and one of them was called the slave drive, i.e. the secondary drive in the system. I don't know if that still applies to SATA somehow, or if that's for something else. It doesn't appear to be anything jumping out at me as to what that is for otherwise. So I apologize, I don't know what that's for. Maybe I can look that up and try to put that in the video in the comment section somewhere, or do like a little annotation in the video if I find out what that's for. But it's going to fit into this little carrier, or caddy, or whatever you want to call it, and then we're going to slide it back in up here, and we're going to lock it into place, and then I'm going to connect the power cable to the back of it, and I will also run a SATA cable to it. Now the SATA connections, I don't know how well we can see these down here or not. The lighting may not be great for this. It might be better if I laid this computer on its back so you can see what I'm getting at, or just a little bit better lighting in here. Okay, now you can kind of see it down here. Hopefully you can see what I'm focusing on, because this is kind of hard to do this with no free hands, but you can kind of see in there they've got like little L-shaped connections inside, just like the back of the drive, because that's where the SATA is going to connect at, the SATA cable. So this is where they are. It's just kind of hard to see them until I tilt it, so you can see what I'm looking at. That's the SATA connections on the board. Usually they have 4 or 6. Some boards have more, like 8 or even 10, depending on how many drives you want to use. If you're going to have a bunch of storage and use it for like some kind of a server or something, and you want to have a boatload of storage, some of them will let you do that. Back in the day when we used to have more prevalent use of like DVD or CD-ROM drives or Blu-ray drives, you know, those are also connected through SATA. But nowadays, most people either don't use those, or like you can use an external one that uses USB or something like that. But anywho, that's pretty much the size of it. These caddies have these little pins on the side, and the drive, you can see, has screw points where you might be able to mount it into a case that uses something like that. But in the case of this, you just kind of set it in here, and those little points will fit into the holes and keep it secured in there well enough. And I'll just set it back into the, like I say, this little thing right here. So give me a second, we'll get it in there. So now you can see we're on the other side of it, and the drive is in this little caddy bay here. And so we've got our little, again, this is hard to see, sorry, connection there for the SATA cable, connection for the SATA power. So I'm going to take, they make 2 different types of SATA cable heads as far as I know. Some of them are curved in an L shape like this to kind of save you a little space if you've got a way to take advantage of it, and some of them are straight edged like this, again depending on how much space you have. But I'm going to go ahead and connect this one. And there's a little clip on the top, so if you want to remove it, you can push down on the clip and then pull it back off. But that's pretty much the long and short of that, which is pretty straightforward. I'm going to route that down through here. All these other cables that are coming in now. Well, that's a lot of cables. This is going to be a fun job of cable management here in a little bit. And then the other part is going to be connecting a power connection to this, which goes like so. And sorry, I'm moving the fan here. Yeah, sorry. All right, I got that in there. Just needed to use 2 hands. And so you can see now that that's connected. That's the last thing we've got to put in except for the video card. And then it'll be a matter of wiring up all the fans to that RGB fan controller from KZYEE. Again, I'm probably pronouncing the name wrong, but I don't know. And actually, I want to wire up the case. That was something I forgot to mention earlier when I was talking about Fusion 2.0, is this lighting again on the front of the case. I think we talked about that earlier, but this will need to be plugged into the 4-pin RGB connection on the board, and I actually need to connect this to our SATA power, so I can go ahead and hook that up there and get that connected. I'm gonna go ahead and put in the video card here in just a second. I'll show you guys that, and then it'll be just about pretty much wiring this thing up, and it should be ready to rock at that point. I can't think of anything I've really forgotten, so give me a second, we'll get that video card in there. All right, one little addendum here. This is where that RGB header was at. So this board has a couple sets of RGB headers. Some of them are in the bottom left-hand corner of the board, but they're now pretty well blocked by the fans that I installed. And considering where this wiring was coming from, it's more convenient to just hook it up here. But there's a 4-pin, which is what this connects to, and then next to that is the 3-pin. As we discussed earlier, this is an analog RGB connection, and this is a digital one. Digital is also known as addressable RGB. I don't know if I mentioned that earlier or not, but digital 3-pin 5-volt addressable RGB versus 4-pin 12-volt non-addressable analog RGB, which is just, again, one color at a time. So hopefully that answers any questions you guys might have. But if you have questions about how RGB works or how it needs to be configured, please ask in the comment section below. I have a pretty good amount of experience working with the RGB software and also working with RGB hardware layouts like this. I've played with quite a bit of different all-in-one coolers and different cases that use it and so forth, so I have pretty good experience. Please ask a question. I have no problem answering it. I love to help. So give me 1 second here and we'll get this video card in here. All right, so I've removed 2 of these backplate covers here that help keep, you know, dust and things from getting into the PC, because this is a dual slot backplate mounting bracket here, so we're going to need that much space to get that in there. This is a PCI Express 16X slot. This is a Generation 4 slot. However, the processor that we're using, the 2700X, is the previous generation CPU, which uses Generation 3 PCI Express lanes. So this card, which is a Gen 4 PCI Express interface, is going to run at 3.0 because of the processor that we're using. This is the parts that I've been supplied with. Maybe, I don't know if he didn't have any, I mean, we were just kind of throwing things together, and it'll work just fine. There'll be almost little to no noticeable detriment to how fast the card will run. It won't really utilize all 16 lanes anyway. It won't use all the bandwidth supplied by, even at 3.0 speed, it should still run at 100 or maybe like 99.5% of its potential speed. I highly doubt you'd notice it in gaming, but there's a slight difference there. And on the newer boards, the reason basically to upgrade to PCI Express 4.0, which you would need a Ryzen 3000 series chip to take advantage of, is, for example, I think later this year, I don't know exactly when, but maybe like mid-year, like July, August-ish, is when I've been hearing, like, for example, NVIDIA will be releasing like their RTX 3000 series cards, and those will be PCI Express 4.0, and like the top end version of those, so like a 3080 Ti, for example, that's their Ampere series that they're going to be launching. Those will probably be able to utilize 4.0 pretty effectively, I would think. Maybe not. I don't know how well they're going to be able to fully utilize the whole socket's bandwidth either, but they'll use a lot more than this card will. And so if you do want to be prepared for those cards to launch and have all the bandwidth possible, you would need, currently this is the only platform that does that, which is the, well, this is the X570 chipset, but any 500 series chipset from AMD, I believe, should be able to give you 4.0 PCI Express. The other advantage to it is the M.2 socket, so that also uses whatever lanes are provided by the CPU. Now this is a CPU that has 3.0 speed, as we mentioned, and this drive that we used is only a 3.0 drive, so it's going to run at the maximum speed it was ever going to be able to. But this socket is capable of utilizing PCI Express 4.0 bandwidth instead of 3.0 bandwidth if you have a CPU that can provide 4.0 lanes. So a lane is like a measurement of bandwidth, is the best way I can describe that. So if you had one of the new Generation 4 NVMe drives and you had a processor which could supply it Generation 4 NVMe or PCI Express lanes, then that drive could be potentially quite a bit faster than this one. So this one runs at, it said, 2400 megabytes per second. Some of the Samsung drives that I've used have had upwards of like 3500 to almost 4000 megabytes per second. The Pioneer drive I did a video on here a couple weeks ago, I think that had like 3400, which is pretty decent. But I know that some of the new ones, the Gen 4s can get to like 5,000, maybe even like 6 or even 7,000. It's over 9,000. Yeah, that'll be the next meme about Gen 4 drives. Or maybe Generation 5 will be over 9,000, who knows. But anywho, that's kind of a breakdown of why you would want to move to this platform instead of using a slightly older platform. Like my Z390 board that my i9-9900K is still using PCI Express 3.0, not 4.0. And so that would be, you know, a reason to upgrade. I'm gonna go ahead and hook up this SATA cable here. I was at it, so I plugged that in. I'm gonna probably try to make that fit a little bit nicer, but I'm just getting it out of the way for the moment. But the video card, the PCI Express connector always comes, well, it usually comes with one of these little plastic covers on it to protect from dirt or from damage. I'm gonna take that off there real quick. Sorry, again, I only have but 2 hands. And for some of this stuff, it's like, I'd rather just hold the camera than set it down. So, we've got that removed. This is what that looks like now with that removed. Shiny little teeth. This is, again, is a Generation 4 card, as is the motherboard. It's just that our CPU is what's going to run it at 3.0 instead of 4.0. So, now, hopefully I can get this in here without... Oh, you know what? That's laid out funny. Okay. I have to make a slight change here. I have to remove this one as well and probably just put it back up here because for some reason this one is lined up with this. Like, I don't even know why that's on there. That's a strange way that they've got that lined out. Well, I guess different motherboards, this might be slightly higher or lower, so maybe that's why they do that. All right, give me 1 second. I got to take out that other back plate. All right, let's try this again. I've got that one removed out of there. It's like it's not wanting to fit in there for some reason. I wonder if that card's going to fit in this system. He might have to give me a different card because it seems like it's landing and laying on this this fan slash heatsink down here that says Gaming X on it. It's like it's kind of landing on that, and I don't have seemingly enough room to push this down all the way. I kind of wonder if we're going to have to go with a different video card. I might have to get back with him and do that. Let me try this one more time, but it does seem like that doesn't want to really fit. If that's the case, that's sort of dumb. Yeah, like I say, that's a bummer. This is, I mean, nothing he could have anticipated, but that card doesn't fit on that board with this case from what I can tell. You know, I may be wrong. Hold on. Let me set this down a second. You know, I was mistaken. What it was is these 2 teeth were rubbing against just like they weren't perfectly straight. I had to kind of push them back a little bit. There's all these little notches down here. You can kind of see one. Well, I don't know if you can see it. The lighting again isn't great for what we're trying to look at here, but there's like little notches where these mesh into the case, and that's where those were trying to mesh into, but they were hitting on the outside, so they weren't quite making it. But I did get it in there. I mean, it's pretty tight fit against that Gigabyte heatsink fan thing down there, but it does seem to have fit in there. It's very flush, so that should be all right. Like I say, it just I was mistaken. It happens. All right, well, the next thing up here is just basically, like I said, I'm going to put 8-pin here, 6-pin here, and that'll be it. Everything will have power that needs to get power. And the last thing for me to do will just be to try to do a nice job of wiring. So, if anybody has any questions at this point, again, please leave them in the comment section. Also, if you'd like to, please give the video a thumbs up if you liked the content, or give it a thumbs down if you didn't like it. But subscribe to the channel if you haven't already done so. I'm really trying to build the channel up here. I'm going to be doing lots more builds. I'm going to be doing lots of part reviews. Again, with my sponsorship now, I have access to get more components that I previously didn't have access to, or at least that I would have had to buy out of pocket, are now being supplied on loan from this gentleman. And so I can review a lot more stuff. If you have requests of things you'd like to see reviewed, please leave that in the comment section also. Any comment you leave helps my channel with the YouTube algorithm by kind of pushing it up the channel or the video list a little bit. But that said, I appreciate you guys watching. I'll go ahead and show you what this thing looks like lit up here in just a second. But appreciate you watching. Thanks for tuning in, and have a great one. Bye.
Thanks for watching. Please like and subscribe.